Have you ever wondered how we solve equations like x squared plus 1 equals 0, which has no solution in real numbers? That's where complex numbers come in. A complex number is written as a plus iota b, where a and b are real numbers and iota is the imaginary unit defined by iota squared equals -1. For example, 3 plus 4 iota is a complex number where 3 is the real part and 4 is the imaginary part. Complex numbers help us solve quadratic equations when the discriminant is negative, extending the power of mathematics beyond real numbers. Complex numbers are added or subtracted by combining real parts and imaginary parts separately. For addition, a plus iota b plus product of c plus iota d equals product of a plus c plus iota times b plus d. For subtraction, a plus iota b minus product of c plus iota d equals product of a plus c plus iota times b plus d. For example, product of 2 plus 3 iota plus the product of 4 minus iota equals 6 plus 2 iota. These operations are commutative, associative, and always result in another complex number. The product of two complex numbers works just like expanding brackets in algebra. Suppose z1 equals a plus iota b and z2 equals c plus iota d. Their product is given by z1 times z2 equals open bracket a c minus b d close bracket plus iota times open bracket a d plus b c close bracket. Let's take an example. Multiply open bracket 3 plus 4 iota close bracket by open bracket 1 plus 2 iota close bracket. Expanding, we get 3 times 1 minus 4 times 2 plus iota times open bracket 3 times 2 plus 4 times 1. That simplifies to -5 plus 10 iota. So multiplication of complex numbers follows the distributive law and is both commutative and associative. The general formula is open bracket a plus iota b close bracket multiplied by open bracket c plus iota d close bracket equals open bracket a c minus b d close bracket plus iota times open bracket a d plus b c close bracket. The modulus of a complex number is like its distance from the origin in the complex plane. If z equals a plus iota b, the modulus is the square root of open bracket a squared plus b squared close bracket. The conjugate of z is written as a minus iota b. For example, if z equals 3 plus 4 iota, then its modulus is the square root of open bracket 3 squared plus 4 squared close bracket, which equals 5. The conjugate is 3 minus 4 iota. Both modulus and conjugate are very useful in division and in solving quadratic equations. Division of complex numbers is done by multiplying both numerator and denominator by the conjugate of the denominator. The formula is open bracket a plus iota b close bracket divided by open bracket c plus iota d close bracket equals open bracket a c plus b d close bracket plus iota times open bracket b c minus a d close bracket, all divided by open bracket c squared plus d squared close bracket. For example, 6 plus 3 iota divided by 2 plus iota can be simplified by multiplying numerator and denominator by 2 minus iota. This makes the denominator a real number and the fraction is expressed in its standard form. Let's recap. We defined complex numbers as a plus iota b. We learned how to add, subtract, multiply, and divide them. We also discussed modulus and conjugate. Complex numbers allow us to solve quadratic equations with negative discriminants, something that real numbers alone cannot do. Beyond theory, they have wide applications in physics, engineering, and computer science. Mastering complex numbers is a gateway to advanced problem solving and deeper mathematical understanding.